All right, so this is lesson 7.3 in Precalculus. All right, so with the cosine and the sine, you have to go all the way around the unit circle from 0 to 2 pi to complete one wave of the curve. The sine starts at 0, goes up, back down, goes up to 1, down to -1, back to 0. So it takes from 0 to 2 pi to complete one wave or cycle of the sine curve. The same with the cosine. I put this on the graph. So one complete cycle, we see one wave, right? The cosine, and this is 0, and that's 2 pi. Begins at 1, its maximum point is 1, goes down to 0, down to -1, and returns to 1. And at each of these points is one of the quadrants, right? This is 0 to pi over 2. This is to pi. This is to 3/2 pi, and that's to 2 pi. These are all one quadrant of the unit circle. So the cosine and the sine, the length of the standard cycle to complete one wave is from 0 to 2 pi. The tangent is different. It has asymptotes. It is undefined at every odd half pi. 1 pi over 2, 3 pi over 2, 5 pi over 2, and all the negatives. All the odd half pi's, it's undefined. Because that's when the denominator equals 0. So its cycle goes from -pi over 2 to pi over 2. So a complete cycle of the tangent curve goes from the 4th quadrant to the 1st quadrant. So we count forward here, 1st quadrant, 2nd, 3rd, 4th. But when we start at 0 and go backwards, we count backwards. This is the 4th quadrant. The next one would be the 3rd, 2nd, 1st, 4th, and so forth, right? So that in order to complete one cycle of the tangent curve, it takes the length of a pi. That sounded sort of strange, didn't it? But it's pi is the distance for it to complete one whole cycle. And its cycle goes from -pi over 2 to pi over 2. Now, we have looked at reflections, vertical shifts, and vertical stretches. Those are the 3 transformations we've looked at. All right, so that is your reflection across, it's a vertical reflection across the x-axis. This is your vertical stretch. That tells me how high up that curve goes, how above the x-axis, and how low below the x-axis goes. If it's 1/2, then it only goes to 1/2. So it's been squashed this way, right? This tells me I've moved it up or down. Here is the point we're moving up or down. That point at the origin. So we would move it up 3. So if I were to graph this one, here's my original x-axis. I have now an imaginary x-axis at 3. I always draw it because it's just easier to draw. Remember, I have my 4 key points. pi over 2 pi, 3 pi over 2, and 2 pi. And I'm going up a half and down a half. So it would be here, 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 and back to 0. So it's the skinnier curve that's been vertically shifted up. Today, we're now going to define this piece, your vertical stretch or compression, as the amplitude. If you see it on the ACT, that's what they're going to call it. This is the amplitude of the function. The amplitude tells you how high above that x-axis it goes and how low below the x-axis it goes. All right, so in our calculators, I'd like for us to graph a couple of things to get you familiar with graphing. All right, first, everybody change your mode on your calculator to radians. Okay, everybody got your mode on radians? All right, go to y equals. Now, you need to make sure that none of your plots are highlighted at the top. Are any of them highlighted? Okay, that's good. So we're going to put something in y sub 1. Let's just graph the cosine of, and here's your variable, right? Here's your variable. The cosine of x, which is really t in your textbook, in y sub 1. In y sub 2, we are going to change the amplitude. All right, so let's graph the cosine of 4x so that we can see a difference. All right. Now, we have to look at our window. We want to see one cycle. So the cycle of the cosine is from 0 to 2 pi. So let's go from negative pi. Let's go from negative pi over 2. All right, so your x min is going to be negative, negative, and you're going to do you see pi in your calculator? It's shift that top caret over 2. And for your x max, let's just go to 3 pi. 3 pi. All right, remembering that your radians is on the x-axis. Now, because one of our, normally you're just going to see to 1 and negative 1. But our y sub 2, we've changed the amplitude to 4. So it's going to go up to positive 4 down to negative 4. So let's make our y min negative 5 and our y max positive 5. Now graph it. So the first one you see is just the cosine of t. Wait, I changed the wrong thing. Go back. Go back to y sub 2. We're going to change the amplitude. It should be 4 cosine x. 4 cosine x. We're changing the amplitude. I changed the period. Now graph it. Okay, makes much more sense. See how high up it goes? So, when we change this value, we change the amplitude, how high up it goes, how low down it goes. All right? Now, we're going to change the period. All right, so let me just give you some information on the period. So if I just have an equation, A is in the place of the amplitude. This is my amplitude. And B helps me determine, it helps calculate the period. B tells me how many cycles between 0 and 2 pi will that function complete. All right, so if we have, I'm just going to say, if we have the cosine of 4t, all right, which is what we graphed a minute ago. If we have the cosine of 4t, this tells me that between 0 and 2 pi, there are going to be 4 complete cycles of the cosine curve. That means, here's what I'm expecting. Between 0 and 2 pi. There's going to be 4 complete cycles. This is going to be hard to draw. There's 1. There's 2. 3. 4 complete cycles. So that tells me how many complete waves I'm going to have between 0 and 2 pi. But it also helps me calculate the period. Here's the formula for the period. The period is 2 pi, the length of your standard cycle, over the value of B. The period tells me over what radians it takes to complete one cycle. So using this example, my period would be 2 pi over 4, which is pi over 2. So 4 cycles between 0 and 2 pi, but to complete one cycle, which is the period, is going to be pi over 2. So the period tells me how long it takes to complete one cycle. And so I should expect between 0 and pi over 2 to see one complete cycle of the cosine curve. Make sense? All right, so now let's go back and let's put this in y sub 2 and compare it. So we've seen the amplitude. Now go back to y equals, clear out y sub 2, and now we're going to do the cosine of 4x. And then graph it. And so the first one graphs, you see one complete cycle, but the second one, you're just 1, 2, 3, 4. And so we've changed the period. So this value changes the period. The B in here changes your period. The B value tells you how many cycles between 0 and pi, and the B value helps you calculate the period. Makes sense so far? Look at example 1, page 495. Determine the period of each function. All right. All right, so the first one, A, is the cosine of 3t. that 3 is in the B position. It tells me that between 0 and 2 pi, there are going to be 3 complete waves of the cosine curve. But what is going to be the period in which it completes one cycle? The period is the 2 pi, which is the time it takes to complete the cosine curve in the standard equation, divided by 3. So 2/3 pi, it's going to complete one wave. Make sense? Okay, look at B. What if we have f of t equals the sine of t over 2? Okay, you can write that as the sine of 1/2 t, right? Now, what does this one say? It's only going to complete half of its wave between 0 and 2 pi. This is going to be a very elongated wave. But what is its period going to be? Its period is going to be the 2 pi divided by 1/2. Well, remember, we don't divide fractions, right? We rationalize this by multiplying by 2 over 1 over 2 over 1. So it is going to take from 0 to 4 pi to complete one cycle, one wave. So this one is going to be a very long, is it the sine? Yes, it's the sine, all right? So we'll just do pi, 2 pi, 3 pi, 4 pi. So it's going to start at 0. At pi, it's going to go up to 1. At 2 pi, normally by now we would have finished already the entire cycle. But now, because we've changed the period, it's only going to complete half of it. So it's going to be this very long wave. Make sense? Very good. All right, look at example 2. Now, the tangent is different. The tangent, so you have to remember, the sine and the cosine, to calculate the period, you're always putting 2 pi over the b value because it takes 2 pi to complete one cycle. The tangent is different. It only takes pi to complete one cycle. So when you're calculating the period of the tangent, instead of 2 pi over the value of b, for the tan, for the period of the tan, it's going to be pi over the value of b. Because remember that tangent goes from the 4th quadrant to the 1st quadrant when we graph it. All right, so in example 2, if we have kt equals the tan of 2t, this tells me there are going to be 2 complete waves of the tangent curve between negative pi over 2 and pi over 2. That's how many cycles we're going to have in its standard period. So, in its standard negative 2 pi over 2 to pi over 2. But what is its period going to be? It's going to be pi over that b value 2. So instead of going from negative pi over 2 to pi over 2, we still have these asymptotes, but it's going to complete 2 cycles. So it'll complete a cycle there. That doesn't look like a very good curve. And it'll complete a cycle here. 2 cycles. such that one cycle takes pi over 2 to complete. So this B value, again, tells us how many cycles in the standard cycle, right, in the standard period. And it also helps us calculate when the period's going to be. All right, what about B? F of t is the tan of t over 3. That's the same thing as writing the tan of 1/3 t. And we're going to do the same. Now, only 1/3 of a curve has been completed in that length of pi. So it's going to take 3 times that to be able to complete one whole cycle. All right. So we take pi divided by that b value, 1/3. But remember, to rationalize it, we multiply by the reciprocal over itself, so that to complete one complete wave of the tangent curve is going to take 3 pi. And you can see that on the top of page 497. You can see it graphed. It goes all the way from 3 pi over 2 to negative 3 pi over 2. They've added a pi on both sides. Make sense? Okay, now we're going to, in example 3, change the amplitude and change the period. So now we're going to go either not all the way up to 1 and not all the way down to negative 1, or we're going to go above 1 and below negative 1, as well as changing the period. All right, so look at example 3. G of t equals 7 cosine 3t. What does that 7 tell me?
Amplitude.
And what's the amplitude? Yes. What's the amplitude? Tell me.
How high and low it goes above the x-axis.
That's correct. Instead of just going up to 1 and down to negative 1, it's going to go up to 7 and down to negative 7. All right. What does that 3 tell me?
It helps you calculate the period.
Okay. It helps you calculate the period. One more thing. Yes?
It takes 3 cycles, or it's 3.
It's going to have 3 complete waves, right?
Yes.
Between 0 and 2 pi. So to complete one wave, it's going to be what? Its period is what? What's the period going to be? 2 pi over 3. So by the time we get to 2/3 pi, it's going to complete a whole wave. All right, so let's just prove that. 2/3 pi plus 2/3 pi plus 2/3 pi equals how much? What does it equal? Yeah. Yeah. 6 pi over 3, which is 2 pi. All right, so we can just divide this into thirds. So this would be 2 pi over 3. The next one would be 4 pi over 3, right? And between, we're going to have well, we're going to go, this is going to be a crazy kind of curve. 7 down to -7. But remember, between we have 3 marks, if I can get them. Because we start out with the cosine, we start at 7, we go to 0, we go to -7, we come back to 0, then we go back up to 7. Then we go back to 0. This is going to be hard to graph. You just alternate 0, positive to 0, down. All right, so this is going to be this very deep, steep curve. Okay, there's one curve. There's 2 curves. And there's 3 curves. So, 3 cycles between 0 and 2 pi. And the length to complete, the period to complete one cycle is 2 pi over 3. My amplitude is 7. All right, look at B. B says h of t equals 1/3 sine of t over 2. All right, what's my amplitude?
1/3.
1/3. What does that tell me?
That only goes up to 1/3.
That's right. It only goes up to 1/3, doesn't it? It's going to be this very short curve, right? And then sine of t over 2. What does that tell me?
If you're gonna have half a cycle between 0 and 2 pi.
You're only going to complete half of the cycle. So what is going to be the period of one complete cycle? 4 pi. So if this were 1/3 and this were -1/3, we're only going to complete half of the cycle. So actually we're going to go maybe about here to here. That's all you're going to see between 0 and 2 pi. Because it would take 2 more pi to complete the other half. Making sense so far? All right, final example, example 4. Determine the amplitude and then graph it. All right, so now we also have a reflection. All right, we're just going to graph it from -pi over 2 to pi over 2. So it's f of t equals -2 sine of 4t. All right. So this tells me it's going to be reflected. So normally the sine curve goes like this, but that's not what we're going to do. We're not going to go up. Instead, we're going to go down. Got it? That's what the negative says. We're reflecting it across that x-axis. That 2 tells me the amplitude. So we're going to go up to 2, down to -2. This 4t says I'm going to complete 4 cycles, right? Between 0 and 2 pi. So what's the period to complete one cycle? It's going to be 2 pi over 4, right? 2 pi over that b value, which is simplified pi over 2. So we're going to complete one whole cycle between 0 and pi over 2. All right, let's just divide this in half. Because we know it's going to go from 0 in between there. It's going to go down. It's going to go back up to pi over 4. In between pi over 4 and 2, it's going to go back up to 2. So we're going to go like this on this side. So going backwards, here's my fourth quadrant. So going backwards, we're going up, back to 0, down, back to 0.